Welcome to the InfoMullet YouTube channel. If you enjoy this content, please like or share. And if you'd like to support the InfoMullet by becoming a mulleteer, visit us on Patreon. We appreciate your support. Thanks everyone for having the presenter. Raafat Zaini has a cold today, so I'm stepping in, but this is work from myself and Raafat. I've shared in the chat a full working draft paper of this poster, and in an order that might help applications like artificial intelligence. It might also help in classifying models and saying, hey, I'm doing systems thinking, but the extensibility of this into system dynamics. Very little in this, I think, is necessarily new, other than the way we've simply ordered it. And so I'm gonna, because with cognizant of time, the primary method we used here on the lower left is we took an analogy to the hierarchy systems of matter. So if you look on the left side, you see what you would say classical physics. There's elementary particles combined into subatomic particles. Those make atoms, chemical elements, compounds, periodic table, we're off to the races. Systems dynamics and systems thinking suggest a very, very similar hierarchy with similar functions and outcomes when you start combining it. So we have elementary structures, which are stock flows, constants, and auxiliaries. We have feedback phenomena, which is an asserted causal loop parameter and causal link. It's an element, but not the entire feedback loop, but it's an assertion of causal phenomenon. For us, the atom of system dynamics and systems thinking is the feedback loop, a complete full positive and negative. And just like atoms can combine in different formulations to make chemical elements, we combine the feedback loops, those create system archetypes. And they can be one or more. It doesn't have to just be, there's obviously a limited number of combinations, but this is also where you get the abstracted microstructures in system dynamics models. And you see here, begin to see that there's a parallel hierarchy. And I'm gonna touch on that in a moment. But as you get to, when you combine multiple system archetypes together, you get what's called a system paradigm. This is a term introduced by Khalid Said. A paradigm is now multiple chemical elements together, which is more like a material compound. And there you have an infinite variety. You have a large variety of potential paradigms you can create. And when we take a paradigm and create a simulation of it, that's where we traditionally call canonical models, urban dynamics, project dynamics, world model. And if we do this visually, I want to just quickly walk through. If you can see here, as I highlight on the lower right, these are the building blocks: stocks, flows, constants, and auxiliaries. So 4 things the world is made of. And really, a constant is a stock with a change value so outside the boundary of interest that it doesn't change. So we just call it a constant. And an auxiliary is a flow that changes so rapidly, or a stock and flow combination that changes so rapidly, it might as be by every dt. These are our elementary particles. When you bring that elementary particle, that structure, in a feedback loop, a feedback phenomena, we're simply asserting this is a stock and flow structure in a single feedback term. It's a plain language term, a plain English term. We are making an assertion. But if someone asked you, hey, break that out, show me how you work, you could go back if you wanted to and kind of extend back into the simulation. The feedback loop, obviously we're very familiar with this. This combines the feedback phenomena. These are the atoms. Archetypes, we're now getting into the sort of the periodic table of archetypes. There's only a limited combination. You combine 2 or more archetypes, you get a system paradigm. This is the equivalent of compounds. And again, when we get to the canonical models, this is simply a paradigm that is expressed in a full simulation. Or you might create a full simulation and then distill it to system paradigms. And there's this concept here we use in this hierarchy of bidirectional extensibility. That means assuming someone wanted to, had the resources to, and the methods to, anything asserted on the left side could also be demonstrated on the right side. A feedback phenomena asserted in a causal loop could be broken down into a stock and flow. A canonical model could be broken down into a system paradigm. This bidirectional extensibility is really the crux of where we're getting to with this unified hierarchy. And I'll go ahead and pause here and take any questions.
Okay.
Thank you, Timothy. Corneille, I see you've got a hand raised.
Yes, thank you, Timothy, for this insightful presentation. I think some of the work kind of talks to some of the stuff I was doing without all the good background you've done. I want to talk about this bidirectional extensibility a little bit and ask you, what I've noticed is that stocks and flows need a lot more detail than this causal loop diagrams. Do you see that there's maybe some transition, that guideline that's needed to, so maybe it's the same causal loop diagram can present many different simulations, but there's not a one-to-one.
Exactly. Depending on your aggregate scope, what you're modeling the problem, a simple word in a causal loop diagram could be one stock and one flow or thousands of them. What we're saying is that it is implicit in the structure that there is stock and flows inside that asserted phenomenon. And again, we're being clear, and we're not saying researchers have to do both because that takes a lot of time. But we're saying when you make a causal statement in a feedback phenomenon, you are asserting a certain combination of stock and flow loops that receive that input from the arrow link coming in and put the output in the nature of the polarity. You can simply say that and put it on paper and everyone can agree and you can move on. But you could also, if you wanted to, distill that into simulation structure, these elementary particles, building blocks of stock and flows. I think when we get to stocks and flows, there's a much crisper definition, mathematical definition of what those constitute and why. But we're showing that how they link together so that there's a little bit of transition that we can say, look, if you wanted to break a system archetype down, this is where you could if you wanted to. And if you wanted to distill a simple stock and flow model, you could do it as an asserted feedback phenomena.
David, you've got a question?
No, it wasn't a question. It was an observation for Tim. Do you know Yaman Barlas's stuff about trying to categorize different modes of behavior? Okay, you know it, right? Because that might be another way of getting at the structure. You've gone from archetypes, you might go from behavior, because basically you're trying to explore that space in the middle, aren't you?
Right. We envision down the road something more of a periodic table that looks, and this is not something we would be solely, that would have, here's the chemical compound that would be like the atomic weight based on the feedback loops, but Yaman Barlas's work of the behavior modes it generates would be right aside. So you could look up and look down and say, here's the archetype 17, fixes that fail. Here's the potential behavior modes that are generated from that, or the connection of a positive and negative, or however that works. We're not trying to be prescriptive. We're trying to start a dialogue of bringing together a sort of rational hierarchy.
Then we've got time for one quick one more. Meyer Matur.
Yes. Hi. Nice presentation. How does your work relate to work on molecules?
So this is, we talked about it because we're very familiar with Jim Hines. We've met him and it can be confusing. Molecules in Jim Hines are small, repeatably usable stock and flow structures. It's almost like a GitHub library of model structures, and those are called molecules. We are not using it in that way, and that does create confusion because we see when we talk about molecules, we're trying to sort of avoid, not step on the toes there, but simply say a chemical element, a combination of system archetypes is like a molecule. It's like a combination of different atoms, just like a molecule would be. So it's a little bit tenuous because that term has already been used, but we think there's room for perhaps expanding that term.
Thank you very much for this presentation. I think that the difficult question I would ask you, and I don't want an answer now, is if you take buzzwords from different disciplines, we use the same word, but they have totally, completely different meanings. How that affects then the different archetypes or causal loop diagrams that would support that, or stock flow diagrams that would support that. So thank you very much. Again, a very interesting piece of work.
Thanks for watching the video. Hope you enjoyed it. If you'd like to follow the InfoMullet, visit us on Facebook or Twitter. And if you'd like notifications when we post new video content, click on the red subscribe button below the video. If you've ever wanted to become a mulleteer and support the InfoMullet, visit us on Patreon. We appreciate the support.